In this video, I'll show you QSAR program. One is this one, VEGA. VEGA, if you just search VEGA, you don't get the program, so you should add QSAR, and you can have VEGA QSAR. I recommend this program because it's easy to use and there are many different prediction models. So it's quite easy. You can just download it. Then you'll have zip file if you download this. So click this button and download it, and then you will have here this zip file. So please unzip through well, you can there's an unzip option in window. So go to inside the folder. You can see this file ended with BAT. So this is called batch file, and you should run this. If some of you are using Mac or Linux, you can check it in the text editor. You can see this is how you run this file. So this JAR, which has the you can see the size of the file is this one is the biggest file in this folder. So actually this is the executable file. So you can just use Java and run this jar file. Then you can open the software. So in the window, since I'm using window, I can just use this batch file to run the program. It takes some time. Okay, it's ready. So here it says insert smiles, or it says import file. So in the last video, I have downloaded SDF file somewhere in the desktop. So here I don't see that file, but it's because of the files of type. So I change to SDF, and then you see this is the file I have downloaded last time. Okay, so please select what tag of the SDF file should be, which should be the ID. So I put CID, which is a compound ID from PubChem, and then I loaded it. So I have file here, or I can just copy and paste Smiles code here, and then click this plus button, and same thing will happen. So now I have my molecule in the program, and then select the model I want to predict. Let's say I want to know, there are many different files that you can try it later, but I want to predict acute toxicity, which will predict LD50 value from the mouse. And then you can check details later, but let's see this one, PDF reports. So I'll also download it on the desktop, and then done. I just click the predict button, the last button, and then it shows the result. So this is the prediction model's result. It says, it says I have already experimental value, and the prediction is this. So this is how I get the prediction value, and I recommend to use this software because of this part, applicability domain. It gives detailed report why the prediction value is reliable. And well, in this case, the structure, its experimental value is already in the software. But in some cases, the model doesn't have exact structure and their experimental value. In that case, it calculates the prediction value, and then they give this report why prediction is reliable or not. So we may go into more detail later, but because of this detailed analysis, I recommend to use this software because prediction value is heavily dependent. Its reliability and accuracy is heavily dependent on the training set if the model was trained with similar compounds or not. So I think this is really nice program. And another nice thing of this model is we can actually download all the training data of this model. So I can download it. Let's check it on the. I'll save it. Okay, I have this file. So I have these files, but I can check it on the Excel, which is better way to check the file. So you can see ID and cast number and smart code. There are many smart code, and there are two types of data here. Normally two types, but I see only training here. We'll go into this part later, and this is experimental value and predicted value. And actually, this is the basic format to develop QSAR model. So you should have a structure and the label of the structure. So label actually means this experimental value. So here this is a structure, and its experimental value is 0.41. It is 0.41 because it's LD50, but when the model is developed, what they use is P LD50. It's minus log of LD50. So that's why values are quite different. I'll go into detail why this is used in this way. But anyway, the important thing is if you want to develop your model, then what you should have first is this structure. And it should be SDF file or Smiles code. You should have list of Smiles code and their activity, so-called activity, which is experimental value. So if you have this pair, structure and experimental value, then you are ready to develop the model. And some says that minimum number to develop the QSAR model should be at least 30. But in some cases, like a nano QSAR is QSAR model for nanomaterial. When the nano QSAR was first published, they were developed with very few data points, like a 10 or less than like a 30, like a 20 or something. So it depends on the situation, but normally people expect to develop the model with a large number of data set, and that is because they users want to have model with a large coverage on the molecular structure. So my main point here is that this is the format of data you need. So you should have structure and activity value, which is the experimental value. And most difficult part is to find the good data, which is labeled, which is the structure labeled with the experimental value, and also this experimental value should be in the high quality. So I told you that I want to talk about which value should be used, and QSAR model can predict any value if structure is labeled, but this label should be measurable property with a clearly defined experimental protocol. That is one of rule mentioned in the OECD QSAR validation guideline. There is a guideline because so many people develop the model. They just train the model without thinking about the users who really want to use the model. So this is a guideline which mentions 5 principles, and one of the principles is the activity. It should be measurable and by the clearly defined experimental protocol. So these are the data we need.